Hi everyone, in this video, this is going to be the first of a couple videos walking us through the Eisenman memorial definition. Um, and this is just kind of getting us up and going from the start. So a couple things that you want to know from the get-go. First off, there's a couple files that you need to download. I distributed these in class, so you should have them. One is a Rhino file labeled Eisenman Memorial. The other is an aerial view. If you don't have those files, which you're seeing the Rhino file here on my screen, I've gone ahead and put them on the Carmen site, so here you go. Just underneath our 5590 Carmen site, go to Files on the left, click on Assignment 01 Attractor Points, and inside of there are the two files that you're going to need for this assignment. Also, to make sure we're all on the same page, I want to show you a couple images just in case you're not familiar with this project to see what we're doing here. So what we have, whoops, sorry about that. Let me go ahead and open up that image again. What we have is the Eisenman Memorial to the Murdered Jews. This is located in Berlin. And it's this kind of irregular site boundary with these blocks. They're called stelas. They're rectangular blocks. And you'll see what happens here is that there's kind of a topography to these. They're in a grid, but then the heights of them vary. Now, I'm not proposing that Eisenman made a grasshopper definition or did this parametrically or anything like that, but I'm just kind of playing with another way that we could come up with a similar design within it. A couple things you'll notice is, like we said, they're on a grid, they're all the same exact dimension. There's high points and low points, we'll deal with that. And one other thing that's important is that the ones around the boundary are also low. So we're going to use the boundary curve as kind of an attractor within it. You can see the irregular nature of the site boundary now that you can see the grid a little bit more uniformed. So we're going to go ahead and work with that. And they all have kind of, like I said, they play off of each other for heights within there. So there's a few images for you. What we're going to do is start with the actual Rhino file that you're seeing here on my screen. Let me go over a couple things that we have on here. First off, it's organized within layers. Notice that the lower left corner is at the origin. It's really important that when we work in Grasshopper, things are going to be based off of that origin. So we want to make sure that we are using that kind of as a starting point. So that lower left corner is the origin. And I believe this point down here is going to be our base grid point. So you'll see if you go to layers, we have several different layers that are happening in here that have to do with the grid. Let me expand that a little bit. But this point that's happening in the lower left is the starting point of our grid that we want to use. You'll see we have a couple of tractor objects. Those are the green objects within here. The red is the site boundary. There's a surface. If I go ahead and set this to a shaded view for a moment, you'll see there's a surface that exists within there. And the last thing is if you turn on the aerial view, you should see the overall view of the site. And this is so that we can start our grid here. Notice that that point is located kind of in the first stela, and try to match the grid spacing with the grid that we're about to create. Again, this aerial view is purely just to kind of match things up. So I'm going to turn it off for a moment. I'm also going to go back just to a wireframe setup like so. The first thing we need to do is launch our Grasshopper definition. So I'm going to go ahead and type in Grasshopper in the command line and let that go ahead and launch. Okay, now that we have that back, I'm going to go ahead and open up my base definition. And a couple things we're going to start with. What I like to do is start off every definition with kind of known steps that we're going to do. So this is going to be the very first step that we have here. This is simply a panel tool, and I've written in the steps that we're going to do. Go ahead and take a moment. You're going to want to copy these down while I start to type and pause the video if you need to do that. But the first thing we're going to do is we need to set up the variables that we have. We've started to do that here on the left. And these are the actual stela or block dimensions. So we know that they're in the x dimension 84 inches and the y 37. And the highest one has a maximum height of 189 inches. Once we've set up some of the variables, we need to create a grid of points. This is going to be a rectangular grid. We're going to import a site boundary curve. We're going to offset that site boundary curve by a diagonal distance. This is because some of the stelas will extend beyond, even though their center points are in the site, the stelas will. This will actually be something we do in a little bit of a later date, so this will just go ahead and kind of type later after this. And last but not least, call or remove grid points outside of the site boundary curve. So that's what we have. To begin this definition, what we're going to want to do is go ahead and start by creating a basic rectangular grid. We've done this already before, so I'm going to move through this fairly quickly because you should be fairly familiar with how this process works. So to do that, all we're going to do is go underneath our Vector tab. We're going to go to Grids. We're going to make a drop in a rectangular grid. Now we used a square grid. The only difference between square grid and rectangular grid is that it uses different dimensions for the cell size and the cell size X, cell size Y. In a square grid, it's obviously the same exact cell size, but it also has a number of cells in the X and the number of cells in the Y. To control these, we're going to go ahead and drop in a couple number sliders. So we're going to go to parameters, go to input and number slider, and there we go. And what we're going to do is we're going to try to match the cell size, the cell spacing and cell size of what the existing grid is. So for right now, all I'm going to do is I'm going to go ahead and just, actually before I copy paste that, let's set up some of these values. I'm going to double click. Within here, we're going to call this, we can say it just as the X cell size. We'll set the other one as Y. We're going to set it for a decimal, but we don't need that much accuracy. Minimum value we'll set up for, say, 1. And the upper limit, let's go ahead and set up for about 200. And don't worry about the actual value for right now, just hit enter. And we're going to copy and paste this slider. And we're going to go ahead and change this to be the Y cell size. There we go. And then we're going to go ahead and set up 2 more sliders for the number of cells in the X and the Y. This time, though, we're going to go ahead and change the X number of X cells. This is always going to be integers. We're never going to have a partial cell. We're never going to have less than 1. Let's go ahead and set the upper limit up for 100. There we go. I'm going to copy paste this and change the second one to be Y. Number of Y cells. There we go. We're going to feed these in respectively. Whoop. Like so. Now, I'm going to go ahead and just kind of dock this over on the right-hand side a little bit. We're going to stretch this out like so. Bring this over a little bit like that. And there we go. Now, you can't really see much of anything. And if you zoom in close enough to the origin, you'll see, okay, there's the start of it. What we want to do is we actually want this point to become our start of our grid. So that's going to become the P input, the origin. So that's a point. We're going to go ahead and drop in a point container. So again, we're going to parameters, geometry, and point container. And we're going to go call this our grid base point. Okay, go ahead and set 1. And click on that point and wire that in. Again, I'm going to go fairly quickly through here, through this whole process. But what you guys can be doing is pausing the video and kind of keeping up as I progress along. Now what we need to do is actually start to adjust these. So this is where the image comes in handy. So what you want to be doing is creating a larger cell size and number of cells in the X and Y to match that aerial view. And you want the crosshairs of the cells to land on the center of those stella. So I'm going to minimize that for a moment. Like so. Turn that view back on. And now what I want to be doing is I want to go ahead and in my grasshopper environment, I want to go ahead and try to expand the cells to get them to match. So as I start to stretch, you'll see, all right, well, we're getting pretty close there. So you'll see the individual cell lines are starting to hit the center, but as I move around, they're not quite spaced enough. So I'm going to keep moving those. That looks a little bit better. And the best thing to do is kind of check the beginning and go all the way to the end and be like, okay, we're again off here and so forth. So go ahead and play with those until you can kind of get them aligned. Again, you're going to be playing with the cell size in the X, the Y, as well as the number of cells in the X and Y. I've already done this. So values I'm pretty happy with are 121 for the X cell size, about 69.5 for the Y cell size. We'll do number of cells as 50 in the X, and 85 in the Y. And you'll see as a result, while it's not going to be perfect, they hit pretty close to the center, and then the grid expands well enough beyond our site boundary. You can expand it even further in the X and the Y if you wanted to. Just remember though that the more points you have, you're just going to delete all these off anyway later on. And it's just more calculating for Grasshopper to have to do. So you kind of want to make sure it extends beyond, but not kind of in crazy beyond. So I'd say 85, 86 in that dimension is pretty good. Looks like we hit our last cell right there at about 50, or last stella right there at about 50, and those spacings are pretty good. So go ahead and kind of mimic my setup here for your number sliders. 121.5, 69.5, 50, and we'll say 85 because that's just what I've got written down here. And there we go. Okay, so now we got our grid of points. The next thing we need to do is bring in a couple different types of geometries. And one of those things we need to bring in is that site boundary curve, because we're going to use that as a way to remove any points that reside outside of our site itself. So to do that, we're going to go to Parameters tab, we're going to go to Geometry, and we're going to use a curve. First thing I'm going to do is relabel this. I'm going to call this my site boundary curve. I'm going to go ahead and set one curve and zoom in and click on that curve in my Rhino screen. Make sure I have it selected, and there you go. There's my site boundary curve brought in. Now, what we get as a result is not only the cells, the actual lines that make up the grid, but also the points. And again, we're going to be focused more on the points. We want to go ahead and remove any points that don't reside inside of our site boundary curve. To do that, we use an operation called cull. To cull means to remove. You're going to find cull underneath sets, sequence, and there's a couple different culls. We want to use a cull pattern. Okay, so the cull pattern requires a couple different things. It requires a list and a pattern to cull or to remove. The pattern currently, if you hover over the P, is false, false, true, true. What it's going to say is no, no, yes, yes. So keep, keep, delete, delete. Okay. If you have more than 4 items, it's going to repeat that pattern. So it'll go false, false, true, true, repeat false, false, true, true, false, false, true, true. What we need to do is set up a pattern that tests whether one of these points resides inside of our boundary curve, yes or no. And we're going to use that yes or no or that true or false to become our pattern. So first thing is what we want to test goes into the list. We want to test all of the points, the grid points. So we're going to take our grid points and run that directly into the list. Now we can't just run the site boundary curve in there because what we need is that pattern. This is asking for a pattern in the call. This is an object, a geometry. We need to test whether or not the object resides inside of this first, then whether that true or false, yes or no, it does reside or it doesn't, it becomes the pattern to call by. Okay? So to test it, what we're going to do is we're dealing with a curve. We're analyzing, and we're testing if a point is in a curve in the lower left, point in curve. There we go. The other option you can always do, there's a couple different options. There's a point in multiple curves. We're only dealing with one, so we're just going to use the point in curve. The P input is the points we want to test. The C is the curve we want to test inside of. You'll see as a result, if I drop in a panel tool, just to visualize this, as a result, we get values of 0, 1, or 2. Okay, that's not the true false thing we're looking for, but if you hover over the output here, you'll see on the text pop-up, it says that 0 means it's outside the boundary curve, 1 means that it coincides, 2 means that it's inside the boundary curve. What we want is all the ones that are inside the boundary curve. Okay, so we want to test these now to see if they equal 2. All that's easy enough to do. All we have to do is do an equality. So go to Math, go to Operators, and Equals, equality here. And we want to test if this value equals 2. So we're going to put a panel tool with 2. Remember, 2 means that it resides inside of it. And there we go. Okay. Now the result of that operation now goes to the true false. And that true false is now our pattern. So the first thing we did was tested with it whether it resided inside of that curve. We got values of 0, 1, or 2, whether that's inside, coincides, or outside. And then what we did was we tested if that became inside or outside as a true false. Okay? We're going to run that as the pattern. And now what you should see as a result is, first off, our overlying grid that resides outside, that's coming from this grid component, but now the points that are contained inside are the only ones that are kept inside of that boundary curve. I'm going to turn off this old information of this grid, just select everything, right click and space, and turn the visual preview off on that. There we go. So now what we've done is we've done these first couple steps. We've set up some of the variables, we've created the grid of points, we've imported the site boundary curve, we've skipped this offset the site boundary curve, we'll do that in a subsequent video, and we've culled or removed grid points outside the boundary curve. We'll start another video that goes us to the next step, which starts to actually create the stellas and then eventually extrude those. Look for the next video here in just a moment.